right, so warm up. A virus reproduces by dividing into two, and after a certain growth period, divides into two again. As the virus continues to reproduce, it will continue to divide in two. How many viruses will be in a system starting with 10 viruses after 5 divisions? All right, so we're starting with n a sub n. So a sub 1 will be 10, because that's how many viruses are in the system to begin with. There's 10. Then what's going to be the next number then? 5? Somebody said 5. Somebody saying 20. In my other class, my other previous 2 classes, I would say what would be the next number, and the first thing I heard was 5. How many viruses will be in the system starting with 10 and after 5 divisions? So what's going on here, let me explain, let me kind of show you what's going on here. So there's 10 viruses. Let me try to draw them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them here. Like in biology, you guys know biology, how you got a cell and it splits and becomes 2. You guys ever seen them? It's one cell and then it just kind of, is it meiosis or something? I forget what they're all called. So you got this one cell, or not a, you might, that's a virus. It splits into 2. So then how many should be here now then? If you understand, if you know what happened here. You don't want me to draw for each one of them. How many total is it going to be now? What is it? 20. Because it split into each became 2. So it's got to be 20. And then what's going to happen after that is that each one of them is going to split into 2 again. So if we're just looking at this part, you're going to have this one is going to go in and become that, and this one is going to become that. So you got 1, and then they're going to go to 2, and they're going to go to 4, and on like that. So if there's 20 here, how many are going to be here? In here? Huh? 40? So that's really what's going on here, is that it grows, no? So it's going to be 10. There's going to be 20. Then it's going to be 40. Then it's going to be what? 80. Then it's going to be what? Those 80 is going to split and become 160. And those 160 is going to, each one of them split, become what? 320. So now here's the next question. Well, you know, let's review what we did last week, no? What's the formula for this? The formula was that it was geometric, and it's a geometric sequence. And that formula was, what was it? A sub n equals what? What was that formula from last week? A sub n equals A1, was it? Times what? R to the power of n minus 1. So in this chapter 8, we have a lot of formulas. And this is one of them. This is for for a geometric sequence. So now, if we, of course, we don't want to be doing a table all the time, but really got to understand the table with the formula. So let's come up with the formula for it. So A sub n is going to equal to what for this particular sequence? What's A1? The beginning amount of viruses, there were 10. And what's happening to those viruses? We're doubling it. In reality, it says, what does it say? That it divides into 2. So you got 1, it becomes 2, which it's actually doubling it, n minus 1. So there's the formula. So this is the formula I'm saying that models this sequence. Let's make sure that it actually gets the correct number, no? If we go and test it for 6, let's test. So we're going to go a sub 6. A6 is equal to 10. 2 to the power of what? 5, because 6 minus 1 will be 5. What is 2 to the 5th power? What is 2 to the 5th power? You guys got calculators quickly if you don't. 32? 32 times 10. 32 times 10 is 320. So it's matching up. 320, 320. This is correct. Everything is good. It is a geometric sequence. Now, here's the next question. Here's I don't think if you ever thought of this question ever. Have you? Have you ever thought of if what is this called? Evolution? If evolution is true, what's the total amount of people that have ever lived? If evolution is true. Have you ever thought, okay, here's another question. Does anybody know how many people are alive right now in the world? How much? About 8 billion? 8 billion, some about 8 billion, no? So right now, there's about 8 billion people alive. Right now, that's how many people are alive. Do you know what the scientists, whoever, have calculated the total amount of people that have ever lived, going back 2,000 years ago, going back 5,000? How many total people have lived? Homo sapiens, or whatever they're called. How many humans? Well, whatever, and that's if you believe it or not, if evolution, 108 billion people. 108 billion people. So, put it roughly, something like this, about 7% of all people that have ever lived, 7% are alive right now. That's a lot. Of all people that have ever lived, 7% are alive right now. That's if you believe all this stuff, no? That's if it's true. All right. It's kind of like the same way of thinking about this, that in a system, in this particular system of viruses, if it started with 10 viruses, what was the total amount of viruses that existed in this system? Well, what are we going to do? Get your calculators, add these up. 10 plus 20 plus 40 plus 80 plus 160 plus 320. What is that? What is that equal to? That is that it came from 10 viruses. And those 10 viruses became 20.
630.
So there was an original that 630. This is 630. That's summing up all these numbers. Is there a formula for this to get it quickly without doing it by 10 plus 20 plus 40 plus 80? Yes, there is. Let me give you that formula. Let's go. The formula is the sum of n numbers if it is geometric, because this is geometric, is A1, A sub 1, times it by 1 minus r, 1 minus r. So it is 1 minus r over 1 minus r, which with one of them being having a power of n. Which one has the power of n? The top one. So the top one has a power of n. That would be the formula for a geometric series where you add up these numbers in the sequence. So let's go ahead and figure out an equation for this particular sequence. The sum of n numbers will equal to the amount of viruses to begin with. What's the amount of viruses? What's the total number of viruses in the system that it began with? It began with 10, no? And then we're going to multiply it by 1 minus what? 1 minus r. What is r? What is r? What is r? What is it saying that is happening? It's saying that it's dividing by 2, which sounds weird. It's actually what? It's becoming, you're multiplying it by 2. Sounds kind of like, it doesn't make sense. Well, I already showed you how it's happening. It divides into 2, which means that it multiplied by 2 in the actual situation. And then to the power of what? Of n, leave it as n, and then 1 minus 2. So this should be the formula for the sequence here. Well, let's test it. Let's test it that it does actually work. For the 6th sequence, better be add up to 630. So let's do a sum of 6. Let's use this formula. The sum of 6 equals 10. 1 minus 2 to the power of what? 2 to the power of 6. And then 1 minus 2. In the bottom of this fraction, the answer should already be what? So we can quickly do it. What's 1 take away 2? Negative 1. So this is negative 1, so we automatically know we got to divide by a negative number. So let's get your calculators and get this. Get a calculator, come up, get a calculator. You need to know how to use this calculator for the test. What I'm going to do is I'm going to do 1 take away 2 to the power of 6. 1 minus 2 to the power of 6. Get an answer. What are you getting? Negative 63. Then a negative divided by a negative, it will become positive 63. So I'll divide by negative 1. I'm getting 63. Once you get 63, you multiply by 10. What's 63 times 10? 630. So this is the formula for any kind of geometric sequence, and this gets you the sum of all those numbers here. And that's what we're going to do today, is we're going to do a geometric series. This is called geometric series. What we're going to do today. All right. Lesson 8D, finite geometric series. Find the sum of the finite geometric series. Well, this is exactly what we just kind of did, no? Where the amount of viruses to begin with was 10, and it doubled. It says that it divided into 2 or whatever, which sounds weird. So what really is happening, it's actually doubling. And then n equal to 6. And we already did it. The long way of doing it, you have to understand both ways of doing it. The sum of 6 numbers with sigma notation is going to be, we're starting with n equal to 1 all the way to 6. And you add those numbers where A1 is 10, R is 2 to the power of that, n minus 1. And if you want to do this the long way, you plug in 1 in here for n. 1 minus 1 is 0. Anything to the 0 power is 1. 1 times 10 is 10. That's why this is going to become 10. You plug in 2. This is the next sequence, 2. So it'll be 2 take away 1 is 1. 2 to the 1 power is 2. 2 times 10 is 20. On and on and on. 3 minus 1 is 2. 2 squared is 4. 4 times 10 is 40. 4, if you plug in 4 in for this n, 4 minus 1 is 3. 2 to the 3rd power is 8. 8 times 10 is 80. Plug in 5. 5 minus 1 is 4. 2 to the 4th power is 16. 16 times 10 is 160. And finally, for the last one over there, n is 6. 6 minus 1 is 5. 2 to the 5th power is what? 32. 32 times 10 is what? 320. Add up all those numbers, and it comes out to be what? 630. But if you know a formula for it, why do all this work when you can just do it by using a formula? And the formula is the one I'm here that I have up there. The sum of these 6 numbers, if it is geometric, 1 minus, r is 2, 2 to the 6th power. 1 minus 2, you got the 10, the initial amount, the initial amount, or the A1. You gotta just know how to put it in the calculator and not mess up, and it should give you that 630. All right. Let's do one more of these kind of problems. Here we go. All right, let's do problem 2. Find the sum of this finite geometric series. It's already telling you that it is a geometric series. So if you have that A1 is 5 and it's tripling, you triple it to get the next one. What would be the sum of the first 10 sequences? Add up all those numbers in the sequence. We're not going to do it the long way. Let's do it using the formula because we believe that it is true, and it is true. So we're going to go with the formula for, and remember it's called the sum of n numbers is equal to a sub 1 if it is geometric, 1 minus r to the nth power over 1 minus r. Let's plug in numbers already then. So the sum of what? The sum of what? The sum of 10 numbers is equal to?
5.
We start with 5. If we continue on talking about various, 5 of them. 1 minus. What is r? 3 is tripling. Triple. What do we plug in for n? 10. So, the way I do this is we do 1 minus 3. Let's get a number for that. What's 1 minus 3 already? Negative 2. You already know that should be negative 2. Get a calculator to do the top part of it. We're going to do 1 minus 3 upon 10. Okay, what are you getting? Negative 59048 divided by negative 29,524 times that by 5. The sum of 10 will equal to 147, 620. So when it is geometric, it usually does go up and get really big quickly. Becomes really big number. Most of this is done by the calculator. You could just go from there to here and get an answer because the calculator will do all the work. All right. Next. I'm moving on. You can go to the website and get the numbers if you miss on this. All right, let me do a little, two extra little lessons here that is I like to do. Because why? Because I always get students saying, when am I ever gonna use this? When are we ever gonna use this math or whatever? So here's an example when you might use it if you wanted to. Number 3, you're buying a new car. You take out a 5-year loan for $15,000. The interest rate that they give you is 3% on the loan. What is your monthly payment? So, if you care to maybe later on when you buy a new car or a used car or whatever, and you go to the dealer, you go to that dealer, you know, car salesman, and you go, hey, I want to get this car, I want to buy a used car, 15,000 around there. Can I? What do you got? And then they go and they say, you know what? Like, look at this car, this one. I'll give it to you, 15,000. Then he goes, of course, that's what they do. How much can you afford monthly payments? How much can you afford? Quickly, they get in front of it. They're over here trying to sell you something. Car salesman, you know. And you tell them, I can make $300 payments. Deal. Because they're taking the little extra money, you know. They're always trying to get. And so you're gonna be like, no. You're not gonna make the conditions here. Hold on. I took high school math and they taught me something. So what's this formula that they used? Because I know that not even the car salesman knows how it works. All he does know is that there's this thing he can push a button and it's a program already, and he doesn't even know that the formula is right here. All he knows how to do is how to sell it, take your money. I'm talking too much. All right, here's the formula. Your monthly payment will equal to. Your monthly payment will equal to, if it's legit and none of those other stuff that they do. If it's mathematical straight up, well, for this, it will be whatever that loan amount you took, 15,000. Multiply that by the interest rate divided by how many payments you're making in a year. How many payments are you making in 12, no? Monthly payments? We'll do that. We'll plug in numbers in a minute. Monthly payments. Then it's going to be 1 minus parentheses 1 plus. I over n, bring it down to the power of negative nt. Well, you're like, how do you remember all this? Well, not really. I forgot it. And so first period, I was trying to remember it, and I kind of messed it up. I said 1 plus, and that was wrong. It's 1 minus. But anyways, you can just look up the formula for it if you really wanted to, and it'll come up. So anyways, look it up on Google or Chat GPT. All right, your monthly payment will be. Plug in these numbers, and you're like, well, isn't there a app or somewhere where you could just, probably there is, I'm sure there is. M. What are we plugging for L? 15,000? What are we plugging for I? The interest rate, which is 3%, and 3% is 0.03. N is what? How many payments you're making in a year? 1 minus 1 plus the interest rate. Well, isn't that we already did it? 0.03, bring it down. 0.03 divided by 12 to the power of what? Negative n. Negative 12 times t. How many years? 5 years? All right, there it is. So you just gotta learn how to put this in a calculator. So I just want to know this already. What's that answer? Negative 60. That's negative 60. All right, the way I do it, the way you want to do it on the calculator, I think if you really do want to do it this way, get a number for the top, write it down, and get a number for the bottom, write it down, and then divide. That's the best way to do it with the calculator. The way even I do it is 0.03 I divided by 12. Let's do that. 0.03 divided by 12. 0.0025. Multiply that by 15,000. 37. What do you get? 37.5. Get a number for the bottom. Let's get a number for the bottom. It's going to be 1 minus parentheses 1 plus 1 plus. It follows what you're doing. You'll do it right. 0.03 divided by 12. Close it with parentheses. Up button. Negative 60. What are you getting? What are you getting? 0.13913 on. Okay, so if you want to be very specific, 139, that should be pretty good. But if you want to do a little more numbers, 13. That should get you the your monthly payment very exact, very closer to what is no rounding. 37.5 divided by 0.13913. 269.53. 269.53. The answer is 269.53. That's how much you would make on payment. Go. 270. About $270. But they usually try to sell you stuff on top of it, and they try to they'll try to take you for $300 a month. Be like, yeah, we can do $300 a month or something. All right, let's go. Continue on. Let's do it. The same formula we use for buying a car is the same formula as we use for buying a house. So hopefully, pretty sometime in the future, you're gonna be, hey, you know what, ready to buy a house. So you're gonna get a new house, and you're gonna have to take a 30-year loan. That's if you don't win the lottery or something, or I don't know what. You already have money for that, but you're buying a new house. You take out a 30-year mortgage for $200,000. The annual interest rate they're giving you 4.5%. What would be your monthly payment? $200,000. Man, time passes by. $200,000. Can I look up how much of the houses are not 200,000 right now? Heck no. Yeah, that's not even a nice house. Oh man. It sucks being poor you guys, man. You guys have to figure it out. That's on you. I'm like, how about? Yeah, I don't even want to hear. I don't even care. Nobody's even buying no car right now. I'm not buying a house. You want the house to go down in price? I can get a house, another house, switch, upgrade. Anyways, this 200,000 was like 15 years ago when I first made this lesson. I've been doing the same lesson a long time. So $200,000, that was like, okay, you could get an okay house. You can't get an okay house with 200,000. Anyways, let's go. Let's do it. So the loan amount, well, the formula was monthly payment will equal to the loan amount times the interest rate divided by N. And it was what? 1 minus, don't forget it's minus, then 1 plus. Bring it down to the negative NT. That's the formula. And so now let's plug in numbers. M equals. What's the loan amount? 200,000. What's the interest rate? Point 0.045? 0.045? For how many payments are you making in a year? 12? Your monthly payments? 1 minus 1 plus. Just bring it down, 0.045 to the over 12. Negative n is 12 times how many years is that? 30 years. You're gonna make a payment for 30 years. 30 years payment. Okay, let's do that. 12 times 30. What's 12 times 30? Let's get this number already.
360.
Negative 360. So let's get a number for the top and a number for the bottom. So I'm gonna do 0.045 divided by 12. 0.045 divided by 12 times that by 200,000. 750. So we got that 750 number for the top, and let's get a number for the bottom. And the number for the bottom is gonna be 1 minus 1 plus 0.045 divided by 12 to the power, close it, to the power of negative 360. I'm getting 0.740, 0.74010. Yeah, whatever. All right, let's go 750 divided by that number. 750 divided by 0.740. 10. How much are your monthly payments?
1,013.
$1,013. And 37 cents. And